Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Welcome to the AVID Technology Podcast with me, Ryan Maughan. So today we've got Manfred Limbrunner from Proton Motor, who are a world famous, I would say, developer of fuel cells and fuel cell systems. A little bit unusually, the company has a headquarter in Newcastle, which is where AVID is based as well. But actually, the operating business is not in Newcastle. And before I start telling everyone all about it, I'm going to get Manfred to introduce himself, and then he can tell us more about Proton Motors. So, welcome to the show, Manfred. Thanks very much for agreeing to join us today.
Yeah, thank you very much, Ryan, for the opportunity to introduce Proton Motor to your listeners. So probably then I start a couple of words to me, to my person. So yeah, my name Manfred Limbrunner. I'm 50 years old now. Not for 50 years, for I think a little less than one month still to go. And I'm with Proton Motor since 2000, November 2000. So it will be my 20th anniversary this year. And I'm a mechanical engineer from the background. So I started out as a project manager, mechanical designer, a system engineer. I also was a product manager for 2 years between 2008 and 2010. From 2010 until 2016, I was also the CTO of the company for 2 years, also in charge of the COO position. And then end of 2016, Proton Motor restructured itself because our goal was to be technologically the leader or one of the leaders. And we saw that before 2016, there was no market really available, or the markets really changed from stationary to forklifts to ships. And we said, we don't chase these small markets, we concentrate on developing. And as soon as we see that the market is ramping up, we restructure ourselves. And this was end of 2016, beginning of 2017. And since 2017, I'm now head of sales and marketing. And since 2018, I'm also a member of the board of the holding of Proton Motor. This is the Proton Motor Power Systems PLC, which is, as you mentioned, based in Newcastle upon Tyne.
Oh, that's fantastic. It is. It's interesting that Newcastle has something of a reputation for being a bit of a hub for clean energy and power electronics and things like that. But it's really it's a sort of an interesting twist of history how Proton ended up with a headquarters in Newcastle. I think a lot of people probably wouldn't actually even realize that that's the case.
I think it's still not to everybody clear how the structure of Proton Motor and Proton Motor Power Systems PLC is. Maybe I can give you a bit of a background how this happened, because Proton Motor wanted to go public around 2002, 2003. That was the start of the discussion. Yeah. And then there was, of course, we first looked for the German marketplace for Frankfurt. But unfortunately, there was the struggle with the new market. And then the stock went down in Frankfurt and in Germany. And it still seemed quite interesting in London. So this was why there was the decision to go public in London. But in order to go public in London, you needed to have a company in the UK. And because the first chairman was coming from Newcastle, John Wall by the name, the company Proton Power Systems PLC at that time was based is based in Newcastle, and we changed the name of Proton Power Systems PLC to Proton Motor Power Systems PLC beginning of this year, because nobody understood that these two companies belong together.
Yeah, because effectively the structure is quite simple, isn't it? You have the holding company, which is listed, and then you have the operating company,
yes,
which is very common. I mean, AVID has this same structure, although we're not listed, but we have a holding company and the trading company. So it's very, very common for businesses like us to do that. It just, it's excellent that you chose Newcastle to do that, and have maintained that until today. It's a really great connection. So just moving on then, I think, Proton's been developing fuel cells and fuel cell systems for many, many years, but it'd be really great just to get a deep picture of what it is that you guys are doing.
Yes, of course. Like you said, we started already very early. So we started in 1994 already with the development of fuel cell stacks. This was not done under the roof of Proton Motor. Proton Motor, this was the mother company, so to say, of Proton Motor, called Magnet Motor. And Magnet Motor did already in the 70s, 80s, and 90s pure electric drivetrain. And the owner said fuel cells could be a very interesting choice also for the future. And it's not very hard to develop, he said at that time. It's like folding boxes. So he started with the development of the fuel cells. So this was the first stack, was a 1 kilowatt air-cooled fuel cell stack. And then in 1998, Proton Motor was founded in Starnberg at that time. And since then, we develop our own fuel cell stacks, and we moved away from air-cooled fuel cells to liquid-cooled fuel cells, because we say we want to go in the high-power sector, and air-cooled fuel cells have a limit at around 3 to 5 kilowatts electric. Yeah. And that's why we started to develop the liquid-cooled fuel cell stacks. We started in 2000. At that time already, there was Volvo Bus for a couple of years, a shareholder of Proton Motor at that time. And we have been a leader in a couple of applications. So we've built already the first world forklift in 2000, which was operated for 2 years on the Munich airport. We built 2 more of them in 2005, 2006, but unfortunately in Europe there was no interest in forklift trucks from the OEM side, or there was no funding implemented. So unfortunately, this again went out of Germany and Europe to the US, and Plug Power is doing what we did already in 2000. Yeah. We did also one of the world's first ship driven purely on fuel cells. This was operated in Hamburg from 2010 until 2014. We transported in this time more than 50,000 passengers in regular transport. We also had, I think, the world's first light-duty truck, which we did with Smith Electric Vehicles, which you might know. Yeah. Because they're based in Newcastle, or have been based in Newcastle as well. Yeah. Former Newcastle business, yeah. So we did a lot of things maybe too early, but now we see that the market is ramping up, and we think that we have the biggest fuel cell stack with graphite bipolar plates worldwide, which has a couple of unique features as well, and we concentrate also just on graphite bipolar plate stacks, because the metal bipolar plate stacks are more for passenger car sector, because they have you can build stacks with very high power density but reduced lifetime. Right. And we concentrate on markets with long lifetime expectations above 20,000 operating hours, and also concentrating where the markets need high system efficiencies.
Okay, interesting. So just, I think probably for the benefit of the listeners, I know, well, and for me, to be honest, because I'm a bit of a fuel cell Luddite, but I do know there's lots of different kinds of fuel cells. And would it be possible for you just to sort of run us through what the options are, what sort of different flavors fuel cells come in?
Yeah, basically, so let's say that they talk about PEM. Maybe if your listeners have heard of them,
Yeah.
And these PEM fuel cells, also there are two parts of them. It's low temperature PEM fuel cells and high temperature PEM fuel cells. So we are doing low temperature PEM fuel cells. They are operated with pure hydrogen. High temperature PEM fuel cells, they operate, as the name also suggests, on a higher temperature level. Yeah. They can run, let's say, with some ingredients on hydrogen that might poison the low temperature PEM fuel cells. So, for example, if you run also with reformat or something, but it seems that the high temperature PEM fuels have a physical limit at 5 kilowatts electric power. And also, you cannot operate them, as far as I know, as dynamic as you can do this with a low temperature PEM fuel cell that we are concentrating on. And then there are a couple of other PEM fuel cells as well. There is, let's say, these fuel cells that run on very high temperatures, above 300 degrees Celsius, like SOFC fuel cells. But these are fuel cells that you more or less have to operate continuously. You should not shut them down too often. Right. So it's more or less like a base load. And we are concentrating on the PEM fuel cells as they are pure emission free. You can run them very dynamic. And this is for these markets of transportation, also for stationary markets in where you need to switch on, switch off, for base loads, for I don't know what you call it in English, for grid stabilization needs. These are the benefits for the fuel cells that we are doing.
Okay, right, got it. So you're in the very clearly in the PEM camp and on the low temperature side. And I think a lot of people think that kind of fuel cells is just one thing, but there's huge differences in the technology and in the application of the varying different kinds of types of fuel cells, which have all been around for quite a long time now as well. So yes, they're fairly mature and well understood technologies. So in terms of low temperature PEM, could you just walk us through how they work? So what's the principle of operation?
Yeah, well, the principle is basically very easy. I mean, you have a membrane that you build into the fuel cells, and more or less what you do, you bring to one side of the membrane air, and on the other side you bring hydrogen, and through the chemical reaction, more or less, you have a catalyst like platinum. You generate electricity, heat, and water. More or less, that's it. And because of water, of the heat, you also have to cool the fuel cell. I mentioned that we do liquid cooled fuel cells. So you bring a liquid inside the fuel cell stack to cool down the fuel cell. That's basically it. Of course, there is a more complex explanation what will happen inside, but I think that the basic principle should work.
Yeah, beautiful in their simplicity, and of course in the past, fuel cells have found lots of different applications. I think in transport there was a big sort of surge of fuel cell interest and development, but there is a bit of a thing now where battery technology has come along. And has developed to a point where, some applications where fuel cells were thought to, going to be like the major energy vector or energy conversion device. They're not. They're not anymore. So what sort of applications are you finding that your fuel cells are well suited to?
Well, the markets we're addressing, I mean, we say we have a very strong, a broad market approach. We say stationary, mobile, rail, and maritime. But like I said in the beginning, we concentrate on markets where our fuel cells fit to. And it's, let's say, I don't see that, maybe I come a little bit away from your question, but I think a big problem is that in the past it was always divided between batteries and fuel cells.
Yeah.
But both are, let's say, electric devices, and both help to overcome their specific problems. Batteries are very good in peak power demand, but are heavy and need long recharging times.
Yeah.
Whereas fuel cells plus hydrogen, they can be refilled very, very quickly. And are, in terms of weight, lighter than the batteries. And since 20 years or 24 years, we say it's a good combination. So it's not the question batteries or fuel cells, but it's a combination, and both could help to enter into the markets. Of course, I think that for passenger cars, the batteries are currently the state of choice. It's the fuel cells and in the passenger car sector will still need a bit of time to increase the numbers. Yeah. Also related to the recharging or refilling infrastructure. So on the transport sector, I think there's now everybody consent over all the OEMs. That let's say trucks, buses, and commercial vehicles, so to say, the best choice are fuel cells plus a battery. On passenger car sector, it will be first batteries, but I think also in the future, fuel cells will take a part in this sector as well.
Okay, that's interesting.
Yeah. But what we always also see, sorry if I interrupt you, because everybody is talking about the mobile market.
Yeah.
But we see that the stationary market is even as interesting as the mobile market, but it's always, everybody's looking on especially in Germany, because of course we have a very strong passenger car market, but the stationary market is getting very, very interesting, because now more or less everything runs toward hydrogen as an energy storage media, more or less. And then there is more or less the side also that you need to bring the grid back to stability, because we shut down the nuclear plants, coal plants. And so there's now currently a lot of interest on stationary as well.
Okay, so you're talking about generating electrical power for the main grid by using fuel cells. I guess that allows sort of demand, matching of demand to generation from renewable energy quite well.
Yes. And also we see increasing interest coming up for, let's say, energy autonomy, if that's the right phrase. I don't know in English, but for example, we have there are 2 houses built with our fuel cells in Switzerland and in Italy, where they included an electrolyzer producing hydrogen from solar or from hydropower, storing this, and if there is less solar or less hydropower to this house, then they use the hydrogen to completely electrification of the house and also heating of the houses. And we see currently a lot of interest coming up also for smaller industrial buildings, and a lot of private people are asking us, but the thing is that we are not a B2C company, so so we unfortunately cannot serve them.
And what do you think the advantage is for that kind of application of a fuel cell compared to, I guess you'd be up against sort of grid storage batteries or some other kind of generation? What is it that why are people looking at fuel cells for that kind of thing?
Because you get into a hydrogen storage system much more energy than you do in a battery storage system. If you look for let's say, residential houses or industrial buildings.
Right. So it's just as simple as that. You can get more power in.
More energy.
Yeah, energy, of course. Yeah. Okay. Get my terminology right. So in the mobile side, it would seem that it's kind of the more kind of heavy duty applications where they've got a big energy requirement, and you're saying,
Yes.
I think quite critically, you said a fuel cell plus a battery, so where the two can work in tandem, and the battery can do some of the work, and the fuel cell provides the kind of base.
Yes.
Is that so for Proton? Is it the mobile application still a significant part of what you're doing as well?
Yeah, it's a significant part for us. For example, we have orders for equipping garbage collecting trucks. We talk to bus manufacturers. We talk to truck manufacturers. It's sometimes a little bit slower as the stationary market, it seems, especially when you talk to bigger OEMs. So it's much slower than on the stationary market, and we see that, let's say, what's happening in China is much faster on the automotive market. I mean, I've traveled 10 years ago already to China, and quite regularly to China, and it was quite clear already 10 years or 11 years ago that China is going in the direction of fuel cells, and we have to be careful now that we don't lose the technology again to the Asian market, which would be a disaster, because the supply chain of the fuel cells is also a very big part, which we would have currently still in Europe. But if we're not fast enough, then we could lose this as well to the Asian markets.
Right. Yeah, and well, that's one of the sort of challenges at present with batteries, isn't it? That it's often sort of said that the particularly the Chinese have done a lot to sort of take advantage of their early adopter position and really kind of seize the supply chain for batteries and the kind of key elements that go into battery systems. So yeah, fuel cells I guess provide the opportunity to be independent of that.
Yeah, I mean, batteries, we have, I think in Europe, we have a couple of, or let's say a lot of battery module producers, but they are more or less buying all the same battery cells. There's just a couple of battery cell manufacturers. Yeah. Most of them are based in Asia, to my knowledge. But still, a battery system is not as complex as a fuel cell system. Yeah? So there is much more supply chain related to a fuel cell than to a battery.
What do you think it will be? In the future for your fuel cells, where do you see the kind of main markets coming? What's the main focus for development for the future? Is it predominantly stationary or predominantly mobile, or a real mix of both?
This is let's say a bit of a struggle that we're facing, or a bit of strategy also what you have to do, because we see that currently, of course, the markets are ramping up very broadly. Yeah, I said stationary, mobile, rail, and maritime. What we are looking at. Also, we got requests from the airplane business, which we cannot do. What we try to do is that we have, let's say, a kit developed, which is can be adapted to all of these markets that we're addressing. So we don't need to develop standard products for every market. So we can relatively easily adapt it to especially customer needs. Maybe a word to the strategy of Proton Motor, because we see that without any, let's say, partners for big fuel cell markets, we will struggle. So we see that we will do, let's say, the development and the manufacturing of fuel cell systems of up to a certain amount, let's say 5,000 equal fuel cell units a year. That's a target that we have in the short term currently. Beyond this, if we're looking also outside Europe, because we currently only focus on Europe, then we're looking for license manufacturers that are going to do the license manufacturing of the fuel cell systems. The stacks we will never license. So stacks will then be produced in large quantity with joint ventures that we are going to found. And then we supply, let's say, from these joint ventures into the free market and into our license partners.
Okay, that's a really interesting way of overcoming some of the those supply chain challenges. I wonder. So we've kind of, as per usual for me, we've completely not following the original plan that I had for questions. So
okay,
it's been really interesting. I wonder if we could just talk for a little bit about the fuel cells that Proton makes and kind of what really makes them special. So in terms of where your kind of key technology is, that would be really interesting.
Yeah, of course. Like I said, I mean, the PEM fuel cell stacks, more or less, let's say also between all the competitors, the basic principles are the same. We have a special, what makes our fuel cell stack special, or let's say the USP of our fuel cell stacks. Like I said, we have the biggest graphite fuel cell stack worldwide on the market, up to 73 kilowatts. Also, what is unique to our fuel cell stacks, because normally from our competitors, to our understanding, you only have one direction of mounting them. Yeah, so you could do, let's say, either horizontally or vertically, and our fuel cell stacks are and you can install in both directions. This is also a special IP relevant issue, how we have developed this. And what is also that our stacks have a modular setup. Right. So we can, let's say, in from powers from 2 kilowatts up to 73 kilowatt, and then also into the megawatt sector, we can achieve this with the modular setup of our fuel cell stacks.
Right, and what is it that allows you to have that flexible mounting configuration?
You know, the issue why of this is how to bring out the water that you produce inside the fuel cell stack.
Yeah, okay.
So and this well, I cannot go too deep into the technology, otherwise AVID will produce our stacks themselves. Yeah, but this is a special design that we have done on the fuel cells, and also which is implemented in our control strategy of the fuel cell systems, which we also develop ourselves. So this and this allows us to offer our customers two different ways of installing them, which gives freedom in packaging.
Right. Okay. It's probably that is an important feature in most applications. And is it the same basically cell that's used in a small system for mobile applications as you would use in a much larger system for stationary? Are they essentially the same thing, but just you mentioned it was a modular arrangement, just kind of more of them, or are there some fundamental differences?
No, the fuel cell stacks are more or less currently the same. So what we did currently for the development, we developed let's say a multifunctional stack for all these markets, because if we develop more stacks, then we will split the volume as well. So the stacks are always the same. And then around the stacks, the balance of plant or the peripheral components are different, and also the setup is different regarding the different applications. I mean, as soon as the market ramps up, then of course there will be the need to develop stacks specifically for specific markets, but this will also increase the financial needs for development. And right. This is where we say we wait until the market ramps up, because development has to be paid somehow from the market in the future, at least.
Yeah. And I know, I mean, you guys are currently developing the product. You have technology that's in the field and deployed, but you're still continuing to do research and develop. What sort of areas are you focusing on? Is it cost reduction or reliability or sort of fundamental performance? Where are you putting efforts to develop the product now?
Yeah, let's say cost reduction, of course, we'll always look at, but cost reduction is a big issue is volume.
Right.
So, and basically what we always say is, or what I say for a rough figure, if we ramp up from one piece to 1,000 pieces, we could reduce the costs by up to 80%. Of course, the price will not decrease that much because we have to develop also the manufacturing behind it and invest into the manufacturing. But the main focus for us is now that we say more or less we have our systems are developed, and now it's going in about industrialization. So we are looking for industrializing our fuel cells, for increasing the volume. We have installed, for example, automated stack manufacturing machine at Proton Motor, which was inaugurated last year from the Bavarian Minister of Economics, right, which allows us to produce up to 30,000 stacks a year. And this is going in the direction of industrialization. Of course, we still have a development roadmap, but like I said, developments, we look closely what are the market demands. Now we have to enter the markets, and developments have to be paid by let's say, winning the markets.
Right. Yeah. So all about then securing more kind of higher volume business that then can pay back in to allow that production process to be further scaled up, and it becomes quite a virtuous cycle then of more scale, less costs, more. And and the fuel cells have to become more mature. And what we also need, I told you that the costs are of course a problem, or prices are a problem, because we're talking about a very low volume market, and fuel cells are always compared price wise to batteries, to diesel or combustion engines. But here you compare a very high volume market with a very low volume market. So in order to overcome this, we also need, let's say, political awareness and political help for market introduction, which has changed now rapidly in the last 12 to 24 months. Was really astonishing of what happened there. But where we say we need, let's say, market introduction help, that the end customers or users are getting the funding and not the company that are developing, because otherwise we're always forced to develop something new. Yeah, it is. I mean, in general, in the electrification space, there's an awful lot happening at the moment, and I think as sort of regular listeners to the podcast would know, I do see fuel cells as being a key part of the electrification landscape. I fully agree with your earlier comments. It's not a competition between batteries and fuel cells. The two can complement each other very, very nicely. But the last kind of 12 or 24 months, there's various things happened around the world with different new regulations, which is driving more electrification activity. And there's been some pretty big movements on the fuel cell side. So I think firstly with there's an American company called Nikola Trucks, and they've obviously been in the press quite a lot recently. Big joint venture with CNH Iveco for fuel cell trucks globally, and then more recently, so like in the last few weeks, was it Volvo and Daimler? Announced. I think Daimler's was a bit sort of double-edged in that they. Am I right in thinking they announced they were stopping for cars but putting all their efforts into fuel cells for trucks? Was that kind of?
Yes. Yeah. I think was 1 week ago or something. They announced that this G class with the fuel cell. Now they stopped, and they're looking for the trucks. And I think they bring into this joint venture the IP that they have developed the last 30 years or something. And Volvo brings in more or less cash.
Right. Yeah. And do you see developments like that as a positive in your space, or is it are these kind of like big guys coming along competing with what you have been doing?
No, I think it's a very good sign. Of course, this will increase, let's say, the interest in fuel cells. Of course, there will be more competition on the market, but competition also helps to increase the speed and decrease the prices. And we see that, all these big OEMs, of course, they also have struggles because they facing currently a lot of different technology tasks. So they need some companies that are developed or have developed the technology. And I also think that there are niche markets what big OEMs will not develop their technology for. They're looking for the mass markets, and they cannot develop them everything for themselves. So we would be let's say a good or even ideal partner for a big OEM that needs the technology and needs a good technology development company.
It's, I guess, interesting how the sort of Nikola model, they've launched a fuel cell truck, but they are bringing the fuel cell technology in from a third party. And I think you rightly point out Volvo and Daimler kind of trying to work together, but also using technology from outside as well.
Yeah, for me, it will be interesting to see, because I know, of course, Nikola, they work together with Bosch as well. Bosch has, I don't know, a couple of months ago, bought a license from PowerCell. PowerCell is doing metal bipolar plate stacks, in our opinion, more or less for passenger cars. Yeah. And what from our discussions with bigger OEMs doing trucks, they also tell us there will be in the future different specifications. So I think it will not be a fuel cell system fitting for trucks, for passenger cars, for buses, or for ships. So there will be different technologies. And of course, we understand that currently the passenger car fuel cell systems try to get into these early markets. Yeah. But in the future, there will be different strategies. I always say, basically, nobody builds into an MAN truck, a Porsche a combustion engine, even it would maybe fit from power-wise.
Yeah, this is something that people, I think, very often overlook, that there's a huge difference between the operating duty cycle requirements of passenger vehicles. Yeah. Even working passenger vehicles, so a taxi, for example, at the very extreme end of the use case, but compared to trucks and ships, where the life cycles, tens of thousands of hours, where a typical passenger vehicle might be 2,000 or 3,000 hours design life. So it's a huge difference. You can't. And in the early days, even in the early days of kind of hybrid trucks and buses, a lot of people tried to use small passenger vehicle engines and as the generator, and that was they kind of were great while they worked, but that very quickly stopped working because they're just not designed to operate for such a long time.
But it seems it's always tried. As soon as there's a new technology coming up, these mistakes are made over and over again, and then they see, okay, we have to separate the technologies.
Yeah, and really the focus for the heavy duty is always going to be total cost of ownership over the life. Yes. So that means you're basically trying to design the product to last the life of the application.
Yeah, and that's where we see, because we say our stacks lifetime above 20,000 operating hours with graphite bipolar plate stacks. The metal bipolar plate stacks, what we see, because we also look into this, is 6,000 operating hours, which is quite enough for a passenger cars, like you said.
Yeah, interesting. It's very different, requirements in those spaces, and even within those spaces. So we see in heavy duty, some applications where it's 50,000-60,000 hours life cycle requirement. Some applications where it's 10,000 hours. Yeah. It depends if it's a medium duty truck or a compact off-highway machine or a very large truck or machine. It's different. It's different again within those sectors.
Yes.
So do you think then? So with all that in mind, I guess clearly you basically what you're saying is that fuel cells, in your opinion, have a place in the market. But it won't just be one fuel cell technology. There's basically space in the market for lots of different types of fuel cells based on the use case. Am I right in understanding that?
Yes, that's what you summarized it very perfectly.
Oh, great, good. I've been paying attention then.
Or my explanation hopefully was not too bad.
Yeah, no, your explanation's been fantastic. So one other side of we talked about renewables and kind of generating hydrogen off the back of renewables in that way. That is a big issue, isn't it? The actual where the hydrogen comes from in the fuel cell system, and kind of getting that part of the energy chain right. Yeah. So what are your thoughts in terms of hydrogen generation and what is happening on that side?
There's currently a lot of happening. I mean, there's also on European side, there's a lot of happening to come to renewable hydrogen. So, I mean, the discussions the last years were always on the energy sector, how to store regenerative energy from solar or for wind. And more or less now everything is running in the direction of hydrogen. So, and there are big efforts to large scale electrolyzing systems. Right. Also, there is huge efforts going in the direction of building up pipeline systems, or let's say coming from using pipeline systems and bringing them to hydrogen systems. There's also in UK, I'm aware of the Leeds 21 project, which is looking for something like this. Right. And this is the goal where to go. Of course, currently we have hydrogen, which is, let's say, gray hydrogen, which is cheap. So you need to use this and come step by step to a green hydrogen community. And I think they're talking about a couple of colors. Yeah, they say gray, they say blue, and they say green. But more or less, you cannot say I just do a switch from totally gray and now totally green. So there will be intermediate steps. I mean, on the passenger car sector with batteries, also it's I'm sure not all of the battery electric vehicles run on pure green electricity. There will be some gray or black electricity also stored in the batteries.
Yeah, no, that's definitely a big challenge depending on how your power is generated. So the electrolyzer generating green hydrogen is, I mean, in some ways it seems like a fairly simple process, because the process you explained earlier of how you generate electricity from hydrogen, it's essentially the reverse of that process, right?
Yes, more or less it's the opposite of the fuel cell.
And is it the same kind of technology in an electrolyzer?
Yeah, basically yes. Yeah, basically what you do, you bring electricity into the electrolyzer, and then it splits, and you bring in water into electrolyzer, and then the electrolyzer splits the water into oxygen and hydrogen.
Easy as that. And for electrolyzer technology, is that something where you would use a low temperature PEM, or is it more kind of some sort of other technology that is more applicable for electrolyzers?
Well, I'm not the complete electrolyzer know-how too much, but let's say, as far as I know, we're talking also on PEM electrolyzers, like our PEM fuel cells, and then there are alkaline electrolyzers. And as far as I know, the PEM electrolyzers also are they can be run very dynamically, and the alkaline electrolyzers have to run continuous.
Right. And I guess it depends, again, as we've been talking about, it depends on the application, because there's some cases where continuous might be okay, but in a lot of cases, if you're trying to kind of peak shave off renewables and store, you're going to need to have a system that can respond dynamically to the to green electricity being available.
Yes. Yeah, I mean, there's for example, in Germany, there's the discussion, we have all these windmills, and we have it's called a renewable energy law or something like this, if you translate it into English, which runs out now. And now the discussion is how, if they will rebuild or tear down the wind parks, or they take it off the grid and connect to electrolyzers. And either way, if it's, like you said, running continuously, if it's completely off the grid, then it more or less runs continuously. Or if I have an excess power inside the grid that I want to use, then I need a system that I can switch on and switch off.
Oh wow! So just tell me a little bit more about that. So there's wind farms in Germany. Is it because they're generating too much power, so they don't need the electrical power, or?
Yeah, basically, if I bring it in simply words, this renewable energy law was installed, I don't know, 10 years or even longer time ago. Yeah. And basically they guaranteed the operators, if you build or operate a wind farm, you get money for the wind farm, even if you have to shut off the wind farm because the grid cannot take it. Yeah? And now this runs out, and now the business cases are changing, and now they're looking what to do.
Okay. So before renewable energy, we were obviously paying as countries and as economies, we were paying for either gas generation, so gas-fired power stations, or in some cases even coal-fired power stations, to sit kind of idling away to provide that response capacity on the grid. So that has always been a thing in large-scale grid systems. You need some spare capacity to help the system. So I know some of these payments to wind farms have been quite controversial, but I don't think people realize that that's just in big energy systems. That's if you don't have a way of storing the energy, that's how you have to do it. So now I guess the option there is we either have to shut the wind farm down, which is not ideal because we're not going to earn revenue, or we put the wind energy into some sort of energy storage so we can store it up and sell that energy back into the grid when it is required.
Yeah, for example, or you can then sell also the hydrogen. I mean, for example, in the Netherlands, there's a political decision to come away from natural gas, and what they are planning to do, I think they're currently setting up already. Also, this is big offshore wind farms where they have electrolyzer hubs, also offshore, and then bring the hydrogen by pipeline onshore. And then either distribute the hydrogen also by trucks for I don't know, let's say automotive or transport sector, or they use it for grid stabilization, for electrifying and stabilizing the grid if there is need for this.
Wow, that's I hadn't heard of that sort of project. That's fascinating. I have to do some more research into things like that. So it's clear that there's a lot of kind of work going on and potential, and I guess from Proton's point of view, this must be one of the most exciting times for the business in terms of that clarity on or starting to get that clarity on a potential large scale end market for your products.
Yes, this is really currently where we see a lot of interest coming to us, which we also have to see that to meet this interest, we have to grow. Yeah, we currently employing people again. Yeah. We ramp up the capacity because we see there is increasing interest and increasing numbers of orders coming now to us.
And so just to finish off, because we're about out of time. In your sort of opinion, Manfred, what is it that's kind of what are you most excited about that you've got coming in the next year or so?
Well, it's I'm astonished how the last 12 months increased. So it's if it goes on like this, or it's like Corona with Corona currently. It's increasing every day. So this is really very interesting for me how to see, and what I'm looking for, and what is very interesting, because we currently have a couple of discussions with strong partners. Also, we're talking to strategic partners, licensees. And this is what I'm really looking for, that we have some really strong partners that help us to go into market, because we alone at Proton Motor, we cannot handle the market demand.
Great. Fantastic. I wish you the absolute best of luck with that. It's Proton's a business I've been aware of for a long time because of that Newcastle connection, which is unusual, but really fantastic to have. So I really do wish you all the best with that. I think what you've done over the last 20-25 years has been amazing. So to kind of be in the right place now to capitalize on that is excellent, and a true it's credit to you and to the rest of the team at Proton.
Yeah, thank you very much, Ryan. And it was a really pleasure talking to you. Also, somebody coming from our home city, so to say. And thank you very much for this opportunity and the very nice and interesting talks to you.
So that's all we've got time for today. That was a fascinating discussion with Manfred, a bit of a deep dive on fuel cell systems and Proton's technology. A fascinating company, obviously, with that really interesting little link back to sunny northeast of England and Newcastle, which I bet many people did not realise that Newcastle had its very own fuel cell company. But a little interesting twist of the past there. So I really hope you've enjoyed today's show. Don't forget to hit like, share this show, leave us a comment. Some fantastic comments coming in. I really appreciate that. It helps us greatly in terms of guiding the content for the show. You can ask us questions if there's a particular topic that you'd like to know more about, or something that you'd like us to cover. You can send us your questions. So that's all we've got time for today. I really do look forward to speaking to you again soon.